Hello everyone, welcome to my class. I'm Dr.P.Ganesh. In this class, we are going to discuss about OSI Reference Model. We all know that the OSI Reference Model, which has been also called it as ISO OSI, it means that International Standard Organization has named it as an OSI. OSI stands for Open System for Interconnection. It means that it is open for any type of data communication. That is why it is called it as a OSI, ISO OSI reference model. Okay, let us get into the class. The main objective of this class is to discuss the OSI model and its layer architecture and to show the interface between the layers. In this, we are going to see how the layered architecture is there, what is an important of this layered architecture, and we are going to see that what is the importance of an interfaces, how it interfaces with the adjacent layers, and then we are going to discuss briefly about the functions of each layer in the OSI model. Finally, to show the functionality of the each layer of an OSI model, how it works with an adjacent layers. Now, what is a network model? A method of describing, analyzing data communication networks by breaking the entire set of communication process into a number of layers. We all know that if you want to perform a data communication, it requires one sender and receiver. In between, we require some transmission media. We have discussed around 5 components of data communication. So, to perform any data communication, there are a lot of analyzing as well as process which is involved. In this model, it has been considered and described and analyzing the data communication networks by breaking the entire set of communication process into a number of layers. So each layer has a specific functions. So each layer will define the functions. It will never overlap with other layer functions. How the OSI model has been evolved. As I said, International Standard Organization ISO established in 1977 to develop an architecture for a system for communication. So this system, this reference model is open for any type of data communication. That is why it is called it as a Open System Interconnection Reference Model. This model allows any two different systems, irrespective of what infrastructure it is, what type of generation of networks, it can communicate regardless of their underlying architectures. The OSI model describes how data flows from one computer. It means that from the sender to an receiver across the multiple networks. The OSI model is not a protocol. It is a very important point. Many people will misunderstood that OSI is a protocol. OSI is not a protocol. It is a model understanding and designing a network architecture that is flexible and more robust. The OSI model consists of 7 separate but related layers because one layer has to do with other layer function. One layer has to collaborate with the other layer, adjacent layer function. So OSI model consists of 7 separate but related layers, each of which defines a part of the process of moving information across the network. Now let us see that 7 layers of OSI model. We will start from top to bottom. Application, presentation, session, transport, network, data link, and the physical layer. Why we need to have so many layers? Why we need to have so many layers? Instead of that, we can have it a single layer which has to perform all the functions. Why? To reduce the complexity, networks are organized as a stack of layers, one below the other. It is a hierarchical in nature, which has to perform first and which has to do next. Each layer performs a specific task. It provides services to an adjacent layers. One layer function should not overlap with the other layer functions. OSI layers for communication, how it happens. Here you can see that the device A, when it is sending a data to device B via the multiple networks, the data will crosses through the two different intermediate nodes. That node may be in a router. So device A will do some applications and it is generating a data. It will goes to application presentation and it reaches to the physical. In the physical layer, the data are going to be converted into signals based on what type of transmission medium the data are going to push. So based on that, the signals are traveling to the across the multiple networks. And then at the device B, at the receiver side, the reverse process will happen. So here the layer 1, 2, 3, the physical, data link and network are the network support layers, and the middle, the transport layer, which is going to link the two groups. The one group is network support layers, which is a physical, data link and network, and another group is the user support layers, that is session, presentation and application layers. An exchange using a OSI model. When the data comes from the device A, first in the application layer, the header bytes are going to be added along with your data. Then each layer, the header bytes are going to be added because each layer will have a separate functions. So to perform that function, it must have some protocol. That protocol will add some headers. If you notice that only the data link layer alone, which will have both header bytes as well as the trailer bytes. So rest of all other layers, which is going to add only the header bytes alone. When it reaches to the physical layer, then the signals are going to be transmitted over a transmission medium, and then at the receiving side, again the reverse process which will perform. Now let us see the layer wise functions. We will start from the bottom. Physical layer. Physical layer is the bottom layer. It is responsible for the actual physical connection between the devices. So here, how you are going to connect the devices to the network. The physical layer is responsible for movements of individual bits from one node to the next node. It means that one node, your device, may be connected to your modem. In what way it is going to connect, whether it is going to be a wired or wireless. According to that, it is going to use the different interfaces. If you look at this diagram, from the data link layer, it is an adjacent layer. The data comes to a physical layer. In that physical layer, all the data are going to be converted into signals. So that signals are going to be transmitted over the transmission medium. The other major functions of physical layer: converts the bits into signals, bit synchronization, manage the physical connection, bit rate control. Depends on what type of transmission medium we are going to use, it will have its own bandwidth capabilities. Line configuration, physical topology on the way in which the devices are going to be connected to a network, and the transmission mode, either it is going to be a wired or wireless, this is a major category, and multiplexing, how many devices and functions, and the switching, whether we are going to use for circuit switching or the packet switching. Next, data link layer. Here you see the diagram. From the network layer, the data comes to data link layer. The data link layer only which is going to add both headers as well as the trailer bits. So the data link layer is responsible for moving frames from one node to the next node. Here, one node to the next node means that node may be either your host or it may be a networking devices. The other functions are framing, divides the data from network layer into the number of frames. the physical addressing. We know that in a LAN network, each devices must have a unique address. Whenever it forwards the data, it has to identify it with the help of unique addresses. So add a header to the frame to define the physical address of both source and the destination machines. And then a flow control. It will regulate the flow of data between the two nodes. It is a traffic regulatory mechanism implemented. The data link layer that prevents the fast sender from drowning the slow receiver. And then error control. It is going to provide a mechanism for error detection, and then there are some protocols to correct an error. Either it may be a single bit error or the burst errors, or it is going to identify the loss of frames. And the feedback mechanism, after transmitting the frames, the system waits for a feedback. Then the network layer. In network layer, data from the transport layer comes to a network layer. In the network layer, which is going to add the header bytes, and then the data moves to the data link layer. The main functions of this network layer is responsible for the source to destination delivery of packets across the multiple networks, whereas the function is more or less similar to data link layer. In data link layer, it is responsible for delivery of frames from one node to the another node, whereas here the source to destination delivery of packets across the multiple networks. The routing, it provides a mechanism to transmit the data over an independent networks that are linked together. So which is going to identify the shortest path between the source network to the destination network. The logical addressing, which is going to add the logical addresses of a sender as well as the receiver. The transport layer, the data comes from the session layer, which is going into a transport layer. In the transport layer, the entire data are going to be segmented. At the receiver side, the reassembly process which is going to perform. It is responsible for source process to destination process delivery of entire message. Here, every system may be running a multiple process. So each process has to be identified separately. Each process data has to be identified separately, which has to be identified and segmented, and the sequence number has been allocated in the transport layer. The transport layer provides two types of services. One is the connection-oriented transmission, another one is connectionless transmission. In connection-oriented transmission, in this type of transmission, the receiving device sends an acknowledgement back to the source after a packet or a group of packets which is going to be received, which is going to make an reliable communication between both the sender as well as the receiver. A connectionless transmission, in this type, the receiver doesn't acknowledge the receipt of a packet or a group of packets. It is an unreliable communication format. Other functions are segmentation and reassembly. When it is sending the data, it is going to segment. At the same time, when it is receiving the data from the network layer, the reassembly process which is going to happen. Divide the message received from the session layer into a segments and then number them to make a sequence for reassembly at the receiving site. Service point addressing. Transport layer makes sure that the message is delivered to the correct process on the destination machine. It has to be identified with the help of service point addressing and the sequence number. The error control. Make sure that the entire message arrives without error, else it has to send a retransmit message to an sender machine. Flow control. The transport layer makes sure that the sender and the receiver communicate at a rate both the devices can handle the packets. Based on that, it will regulate the flow of data. Now see the functions of session layer. Now the data comes from the presentation layer. Based on that, it is meaning that the dialog control, the machine dialog control, it is responsible for beginning, maintaining and ending the communication between any two devices, which is called an session. Establishment, maintaining and ending a session. It uses the synchronization packets to establish a request, same time acknowledgement and synchronization from the receiver. To end the connection also it uses an acknowledgement signal. So the dialog control, the session layer allows two systems to enter into a dialog to maintain the error and flow control. Synchronization allows a process to add the checkpoints to a stream of data without affecting the syntax and semantics of an information. Presentation layer functions. In the presentation layer, the data comes from an application layer where any modification of the data which is going to be performed in the presentation layer alone. So this layer is concerned with the syntax and semantics of the information exchanged between any two systems. In general, we call it as any modification of the data, or if you want to provide the security and privacy to your data, you can add some protocols into that presentation layer. The data translation, it can use encoding and the decoding mechanism, sender to common format. On the sending side, that same thing has to be used at the receiving side so that it can able to retrieve the original message. For example, if one sending system is going to use one data encryption method, the same de-encryption method has to be used at the receiver side to retrieve its original data. So the data encryption will provide an security and privacy purposes, and the data compression, any modification data compression reduces the number of bits contained in the informations. And then last, application layer. Depends upon the applications what the user wants to use. Based on that, they can use the multiple protocols. If they want to use a email application, email protocols, and then a file transfer means file transfer protocol, FTP. If they want to browse, HTTP, www, there are n number of protocols which is available that varies from one user to the another user. The user free to use any kind of application protocol to create its own data and add the headers and send it to a presentation layer. So that provides user interface and support for services like email, file transfer, virtual terminal, remote login, any type of applications, they can use it in the application layer. Now, let us recap, let us summarize what we have discussed now. In this OSI reference model, we have seen how OSI has been evolved right from 1977 and why it has been named as an ISO OSI reference model. And then we have discussed about why it must have multiple layers, say for 7 layers in this OSI model. And then what is the need for each layer and what is the thumb rule. The layer function should not duplicate, it should not overlap with other layer function and specific functions kind of things. And then we have seen that how the data will flows from one device to the another devices. Based on that, the layers also grouped into two groups. One is a network oriented, another one is a user oriented groups. The network oriented, physical data link and network, and whereas user oriented, application, session and presentation layers. The transport layer, which is going to bridge the two groups in that single OSI reference model. And then each layer we have discussed about what are all the major functions and what are all some of the protocols which has been used in that particular layer. Hope you have understand the OSI reference model concepts it clearly. If you have any doubts, you can write on a comment. I'm ready to respond to your queries. Thank you for watching my class. Have a good day. Thank you.